Alright, in this video we're going to take a look at how to solve an equation that just happens to have one of these things. We call that a rational exponent. What it really means is an exponent that can be written as a fraction. And there's a meaning behind these that we'll get into as we get further through the problem. We're going to try to unwrap it and see what is this really telling us. Now first, we start these just like we would any other problem. Okay, usually when you're trying to solve a linear equation, well, first thing we would do is subtract 1 from both sides. That doesn't change. A lot of your instincts still apply to this kind of problem. So on this side we get 192, but over on this side we have 3x to the 3/4. Now, next step is very crucial. You have to ask yourself, what does this exponent right here apply to? Okay, does it apply to the x or to the x and the 3? That's a big deal. Now in this case, there's no parentheses that connect the 3 and the x and say that they both have an exponent of 3/4. So in this case, what this really means is 3 times x to the 3/4 equals 192. I know it isn't written this way, but that's what it represents. And the reason this is important is this 3 has absolutely nothing to do with that exponent. It's just a multiplier. It's a constant that's multiplied by that value. So we're going to move it to the other side by dividing. Now when we do that, we're going to be left with x to the 3/4 equals 64. Okay? Now this is the moment where you kind of have to step back and think about this. Okay, it looks a little weird. Sometimes it's hard to process what this means, but right now we can start putting some meaning to the numbers. Okay? Notice we have x to the 3/4 power. Now if I want to undo that, I'm going to need to raise this to another power that somehow makes my exponent become 1. So I'm going to use the reciprocal of 3/4, which is 4/3. But if I do that to one side, I must do it to the other. All right, now let's take a look at where this gets us. X to the 3/4 raised to the 4/3. Well, when I multiply those together, I get 12 over 12, which is just x to the 1. Okay, we're just going to write that as x. Okay, so my unknown number is 64 to the 4/3. Now, sometimes this is not a nice number. In fact, a lot of times it's not a very nice number. It's not something you should know in your head. A lot of times you are just going to take whatever you get, and you're going to grab your calculator and write 64, and then you're going to do your little exponent key, the little caret, whatever it happens to be on your calculator, and you're going to raise it to the 4/3 power. And that will get you an answer. But occasionally, you get a nice number that you can interpret in your head, and this is one of those scenarios. So I want to remind you what this means. If we would like to do this in our head, this is 64, and this right here has a representation we've talked about quite a bit. Okay, that 3 really means it's a cube root, and the 4th is an exponent. Now this happens to be a nice number you should know. 64 is a perfect cube. The cube root of 64 is 4. And 4 to the 4th power is 256. Okay. Now, that's the answer to my solution, 256. But what we're going to find is, as we get more and more complicated with these, it's always a good idea to go back, plug that answer in, and see if it makes a true statement. See if this stuff right here, that actually equals 193. Because occasionally we're going to run into what's called an extraneous solution, which doesn't mean the math is wrong. We get all the way through this and we find a solution and we go, oh, that's it, right there. But when we try it in the original equation, for one reason or another, it doesn't work. And we'll get into what those are down the road. So there's solving an equation that has a rational exponent.